So welcome back to Space. Today we are going to solve exercises in chapter number 4, Theory of Profit and Market Structure. And we are going to solve the question number 10 in this chapter. And this is very easy problem. So the problem is find the, you are given the profit function pi equals, or profit function pi equals r minus c. Profit is a function of all our functions of q. So profit equals total revenue r minus total cost q. So we have to find the necessary and sufficient condition for profit maximization. So we know that necessary condition is first order condition, which is first derivative equal to 0, and sufficient condition is second derivative should be negative for maximization and positive for minimization. So as we are doing profit maximization, so we are going to deal with this. So take the first order condition FOC, which is necessary condition, which implies necessary condition. And second order condition is called sufficient condition. Okay. Now, what is first order condition? If we take del pi divided by del q should be equal to del r del q minus del c del q should be equal to 0. Okay. Then we can rearrange this and find that this is nothing but MR, marginal revenue. So marginal revenue is total revenue divided by del total change in total revenue divided by change in quantity, and marginal cost is DTC divided by DQ. So this is our marginal cost. So marginal cost should be equal to marginal revenue. So this is our first order condition. We can call it first order condition. Now, what about the second order condition? Second order condition SOC. We take the second derivative of this above equation. Then we can say that del squared I divided by del Q squared should be equal to del squared R divided by del Q squared minus del squared C divided by del Q squared should be less than 0, which is, we're talking about maximization problem, so we need to set it as less than 0. So if we rearrange this, we can find that this is nothing but the slope of MR. So the slope of MR should be less than the slope of MC. That means in the language, we can say that MR curve cut the MC curve from below. Okay. We can show this graphically. So we know that our TC curve looked like this. And we can draw our TR curve like this. TR curve. And we need to find out, this is actually break-even point. And this region is our profit region. So we need to find out a Q star here, Q star between these two points, Q1 and Q2. This Q1 and Q2 are Q2 equal to break-even point. So in between the Q1 and Q2, we need to find maximum profit. That means the distance, it is maximum. So the maximum distance is that distance which is supported by the parallel of MC. That means the slope of TC. This is nothing but the slope of, this is the slope of TR, that means total revenue, and this is slope of total cost. So this slope equals means here the slope should be parallel to each other. Okay, so when we find the parallel slope, suppose this is our parallel slope. So parallel slope should give the maximum distance here. Okay, so this is our maximum distance. So this is actually Q star. All other slopes are not parallel. So when you see that non-parallel slopes, that means these slopes are actually MR. This slope is actually MC. Slopes are MC and MR. But I mean, MR and MC equal means these, they are parallel to each other. Other than those, two parallel curves, all are giving less distance. So the distance is actually profit. So we can draw a profit curve under this curve. So if we draw a profit curve here, IQ. So profit curve should be starting from the to break even. So at break even, where profit is 0, and our profit curve should start from here, reaches at the 0 at break even point, and maximum point should be there, somewhere there. And this is maximum, and then fall down. So this is our pi curve, T pi curve, total profit curve. Okay, so this is the maximum, all right, total profit. So this is our profit curve. Now, how can we visualize the second order condition? That means MR curve should cut the MC curve from below. Let us visualize this. So let's draw to visualize second order condition. That means in a sufficient condition, we can draw MC curve and MR curve. So we know that our MC curve look like this. This is our MC curve. And this may be our MR curve. So the second order condition says that MR curve should cut the MC curve from below. So we found that two cutting point. So here, MR curve cut MC curve from above. So this cannot be a sufficient condition. So this is not sufficient condition. Here you see that the MR curve cut MC curve from below. So this is our sufficient condition. This fulfills our sufficient condition. Okay. So this is our Q star. All right. And this is not our Q star. This Q star is it is fulfilling the first order condition. First order condition, that means necessary condition NC, but not SC. Here, both NC, necessary condition, and sufficient condition fulfilled. At this point. So this is SC, not SC here, and SC. Okay, so let us see that whether this slope of MR is greater and less than slope of MC is fulfilled or not. So you see that here, MC curve is positive slope, so and MR curve is negative slope. So this point is satisfied. this condition. The slope of MR should be less than the slope of MC. Okay. All right. So this is the graphical depiction of the solution of the problem. So we found necessary and sufficient condition for profit maximization. Let's move to the second problem of this chapter 4. So what is this second problem? Second problem says that Munno Group has the following revenue and cost relation. So our revenue should be P equals 50, and because price is fixed, that means this is actually the inverse demand curve. So price is fixed, then our total revenue is 50Q. GR is 50Q. And MR is 50. So we have got the P as well as AR is 50 divided by Q equals 50. So we have got the condition that, we have got the situation that P equals AR equals MR equals 50. So it is nothing but the problem of perfectly competitive market. Okay. And our cost function TC is 720 plus 18Q plus 0.2Q squared. This is our total cost curve. And we can find the MC from here. MC is nothing but 18. Remember that MC is equal to DC divided by DQ. MC is 18 plus 0.4 Q. Right? Now, the statement says that find out profit maximizing activity level of Q star and pi star. So at profit in the previous equation, we know from the previous equation, we know that profit maximizing activity level, profit maximizing activity level at profit maximizing activity level, that means Q star and pi star. We are going to find this Q star and pi star. And at this level, we know from the previous solution that the condition FOC, first order condition, is MR equals MC. So this is our first order condition. So we can find the solution to this problem is MR. We know that MR is 50. So here this implies 50 equals MC is nothing but 18 plus 0.4 Q. So we can rearrange this. As 0.4 Q equals 32. Q star that equals 32 divided by 0.4, which is equal to 80. Okay. So we have got our one solution. That means this is 80. And how can we find the second solution? Faster. So we use the profit function. That means pi equals TR minus TC. And now the TR is 50Q minus TC is 720. 720 plus it will be minus 18 Q plus minus 0.2 Q squared. And if we insert this value in this equation, we get 50 times 80 minus 720 minus 18 times 80 minus 0.2 times 50 and 80 squared. Which is equal to, by using the calculator, we can find that this is 560. Okay. So our this is our pi star. So we can find the pi star here, 560. So we can say that the solution to this problem is Q star pi star is equal to 80 and 560. This is our solution to this problem. Okay, so we are now going for the next solution. Solution to the next problem. Problem number 12. It says that Niloy Corporation faces the following inverse demand and cost function. So our inverse demand function P equals 60 minus 0.5 Q. Why it is called inverse demand? Because we know the demand function is Q is a function of P. But inverse demand function is demand function. And inverse demand function is P is a function of Q, which is demand function inverse. Okay. And our TC is here, let me write down TC here. TC is 125 plus 5Q plus 0.05 Q squared. And we need to find out the revenue maximizing activity level. That means our problem is, first we are going to find the revenue maximizing activity level, P star, Q star, and pi star. And then we find the optimal level of price, profit maximizing activity level of P star, Q star, and pi star. Okay. So let's try this. So from here, this equation, we can find the TR equals PQ equals 60 Q minus 60Q minus 0.5Q squared. And from this, we can find MR equals 60 minus Q, 60 minus Q. Why? Because we take this first derivative of this, MR equals TR del TR del Q. Okay. And MC equals del TC del Q, which is MC equals 5 plus 0.1 Q. Okay. So we know that revenue maximum at our revenue is TR. So revenue maximizing activity at revenue maximizing activity level we know that first derivative of this TR should be equal to 0. So if we set this, we can get P star, Q star, and pi star. So here we see that TR equals 60Q minus 0.5Q squared. So dTR dQ should be equal to 60 minus Q. It should be equal to 0. And from this, we can get Q star equals 60. And insert this Q star equals 60 into P star equals 60 minus 0.5 times 60 equals 60 minus 30 equals 30. Let's start it. All right, so from this, we can find profit. So pi equals, again, TR minus TC. And we know that TR equals 60Q minus 0.5Q squared minus 125 minus 5Q plus 0.05 Q squared, which is equal to 55Q minus no, this is actually minus. So 55 0.55 Q squared minus 125. So we can put the value Q star. So 55 times 60. Times 60 minus 0.55 times 60 squared minus 125, which is equal to 1195. If we use the calculator, we will find 1195. So this is actually pi star. So we have got the first solution to this problem. Okay, first solution to this problem. So our solution is P star equals 30, Q star equals 60, and pi star equals 1195. Now, what about the second part of this problem? That means optimal level of price output and profit. So we know that second part. At optimal point, optimum, MR equals MC. That means our 60 minus Q equals 5 plus 0.1 Q, or we can say that 0.11 Q equals 55. So Q equals actually 50. So we have got Q star here. Q star equals 50. So let's erase this part. Sorry. So at revenue maximizing activity, not revenue here, it is profit maximizing activity level. At profit maximizing activity level, MR equals MC. This is the condition for profit maximizing activity level. And we're going to find this. Okay. So as we found from this, we found Q star. Q star equals 50. Then we can make this as P star 0.5 times 50. So 60 minus 25 equals 35. So here Q star equals 35. P star 50, P star equals 35. So P star equals 35. Now we are going to find pi star. So here we can use this equation as well. So we can erase every time we see that 60, then we can make it 50 and get pi star. So let's do it. So here we insert 50. There we insert 50 squared. So this is actually not 1195 now. It will be, if we multiply by 50 instead of 60, we can get the value 1250. So this is 1250, which is equal to pi star. So here we can insert pi star equals 1250. So now from this the solution to this problem can be written here. So first part, P star, Q star, and pi star equals P star equals 30, pi star equals Q star equals 60, and pi star equals 1195. Number 2, P star, Q star, pi star equals 25, 50, 1295. So this is our solution. To the problem number 12. So this is the end of our chapter number 4 exercises. Thank you very much.